Question number 7 says, in a game, players attempt to score a goal by kicking a ball into a net. The probability that Lino scores a goal is zero point 0.4 on any attempt, independently of all other attempts. The random variable x denotes the number of attempts that it takes Lino to score a goal. Find the probability of x equal to 5. That means Lino took 5 attempts to score the first goal, which indicates that it's a geometric distribution, because whenever he scores a goal, then the experiment is over. That means when the success is attained for the first time, or the word until is written in the question, it indicates that it's a geometric distribution, because whenever someone succeeds, then experiment is over. So let us start our solution. X is geometric distribution, and for geometric distribution the parameters are only the probability, independent probability. Individual probability is zero point 0.4. So we can see that P is zero point 0.4, whereas Q, that means failure in every attempt, probability of failing in every attempt is zero point 0.6. Well, then we will find that probability of x is equal to 5. We know that the formula is, look, if we analyze that on the fifth attempt he succeeded, that means among the first four attempts he did nothing but fail. So we will write 4 times he failed. The probability of failing is 6.6 raised to 4, and once he succeeded on the fifth attempt. So 1 success, 4 failure. If we calculate this, it is going to be 0.6 raised to 4 into zero point 0.4. If we use our calculator, it is going to be 0.518 if we round it up to 3 significant figures. That is what the answer to this part. Then the next question says, probability of 3 until 7. That means he attempted up to 7th attempt. Among these 3, we will have to find the probability when x was 3 until 7. So let us analyze the question. Look at this. This is, suppose here there is 2, 3, 4, 5, 6, and 7 attempt. So 7 attempt is here, and third attempt is over here. That means we will have to find the probability of this portion. This is his probability. So for this probability, what we will do, we will find the probability of 7th attempt, succeeding on the 7th attempt. Then we will subtract this left part. Okay, and as you know, we are still under the same geometric distribution. Geometric distribution is nothing but a discrete random variable distribution. As this is discrete, applicable for discrete random variable, we will subtract just less than 3. Less than 3 means it's actually 2, the probability of succeeding in 2 steps. So simply what we will do, we will find the probability when he succeeded on or before 7th attempt. Okay, that means less than or equal to 7th attempt. Then from this probability we'll subtract the probability of when it was 2. That means x equal to 2. So let us write probability of 3 until 7. 3 until 7 is equal to probability of x less than or equal to 7 minus probability of x less than or equal to 2. Well, so we know the formula for probability of x less than 7 or equal to 7 or less than 7, it is 1 minus q. Our value of q is, we have already written here, value of q is zero point 0.6. So it is 0.6 raised to 0.6 raised to how many times? 7 times, minus 1 minus minus plus probability when x is less than or equal to 2, the same formula, zero point 0.6 raised to 2. So our probability is going to be, 1 can be cancelled by each other, so 0.6 square, that is 0.36 minus, so let us use our calculator. 0.36 minus 0.36 minus 32.332 is our probability. So I think you have got my point, that they have told us to find the probability from when x is from 3 until 7. First we have found the probability when x is equal to or less than 7, then from that we have subtracted the remaining probability, that means before 3, as this is for applicable, geometric distribution is applicable for discrete random variable, so less than 3 means actually 2. Okay, so we have found the probability of x is equal or less than 2. If we subtract this probability from the probability when x is equal to 7 or less, then we will find the probability in between 3 until 7. Then question number C says, find the probability that Leno scores the second goal on or before his fifth attempt. So it's a little bit lengthy question. It cannot be solved in one step. One after the other we will have to solve this. So maximum attempt was fifth attempt. So for fifth attempt, let us see what are the possibilities, what are the cases. Okay, suppose he succeeded for the second goal in the second attempt. So this is the first case. Probability of second goal on second attempt. Suppose he succeeded on second attempt. So what is the probability? It means on the first attempt he scored a goal for which the probability is zero point 0.4, and on the second attempt also he succeeded scoring a goal. So probability is going to be 0.16. Okay. Then he might succeeded for the second goal, scoring second goal on the third attempt. So second goal on the attempt third attempt. If it is so, so one attempt is sure that he succeeded on the third time. So for the third attempt it is nothing but success, he succeeded on the third time for the second time. But what about the first two attempts? Among the first two attempts we don't know when he got succeeded, that means it's binomial distribution. So one success among the first two attempt and one failure. The probability of failing in each of the attempt is 0.6. So what is it going to be? It is going to be 0.6 into 0.4, that is 0.24. So 4.24 is 0.96. If 0.96 is multiplied by 2, it is 0.192. 19 as well as 2. 192. 192. Third case, probability of second goal on the fourth attempt equal to, So on the fourth attempt, it was second goal. So definitely on the fourth attempt, there was success. Now among the first three attempts, we don't know when he got succeeded. So there was one success, two failures. So one success is, it is zero point 0.4, one success and two failure. And probability of each fail is zero point 0.6, it's two times. Let us calculate this. If we simplify this, it is going to be equal to 0.4 into 3, choose 1 is also 3, and zero point 0.4 into zero point 0.6 square. So finally it is going to be 0.4 square, 0.6 square into 3. Let us use our calculator. 0.4 square, 0.4 square to it. 0.1728. Well, then the final possibility that he might succeeded on the fifth attempt. Okay, second goal on the fifth attempt. Second goal, probability of second goal on the fifth attempt. Fifth attempt. Okay, so on the fifth attempt, second goal means on fifth attempt there was nothing but success. He scored a goal for the second time on the fifth attempt. But about the first four attempts, we don't know when he got succeeded. So among the first four attempts, there was one success and three failures. Three failures. So it is going to be zero point 0.4 square into 0.6 cube, and 4 choose 1 is 4. So let us use our calculator. 3 times failure, 2 times success. So success 2 times, failure 3 times. Point 0.13824. Then we will write the probability of second goal, probability of hence probability of second goal on or before fifth attempt, fifth attempt fifth attempt. Then let us do all of these added to each other. If we add up, it is going to be equal to, so 0.13824 plus 0.1728. Let us use our calculator. 0.1728 plus 0.1728 0.663. So our probability is 0.663. 0.663 is our final probability, and that is the final answer to this question. So I think you have understood that, as they didn't tell any particular attempt of success, they told that it should be he succeeded for the second time on or before fifth attempt. On or before fifth attempt. So what are the possibility he might succeeded for the second goal in the second attempt? In the second attempt, suppose he succeeded in the second attempt, for which the probability is this, and he might succeed on the third attempt for scoring two goals, and he might succeeded on the fourth attempt for scoring two goals, and finally he might succeed on the fifth attempt to score two goals. And if we sum up all of the probabilities, we will get 0.663, which is the final probability. Let's move on to the immediate next question. The next question is, Lino has 75 attempts to score a goal. Use a suitable approximation to find the probability that Lino scores more than 28 goals but fewer than 35 goals. So, approximation is the clue word. Remember, whenever the word approximation is used, it indirectly discloses that you will have to convert the given binomial distribution into a normal distribution. So our distribution is given binomial. X belongs to binomial distribution, and you know the parameters for binomial distribution are mean as well as probability of each attempt. So mean is, sorry, n and p. N and individual probability. N is 75. The parameters for binomial distribution are n as well as probability of each event. 75 is the total number of attempts, and probability of each attempt is zero point 0.4. From the previous question we have got that scoring a goal, probability of scoring each goal is zero point 0.4. Well, it is to be converted to a normal distribution. If we convert into normal distribution, the parameters for normal distribution are mean as well as variance. So mean is actually n into p. Okay, x belongs to n. X belongs to n, and parameters are mean. Mean means n into p, so 75 into 0.4, it is 30. And the variance, the other parameter is npq. Np is 30 and q is 0.6. P is equal to, p is 0.4, and whereas q is equal to 0.6. If we multiply 30 by 0.6, it is going to be 18. So these are the parameters of the normal distribution table. So they have told us to find the probability of, look at this, more than 28 goals. More than 28 goals but less than 35 goals. So more than 28 goals but less than 35 goals. So if we observe the question, we are converting a binomial distribution into a normal distribution, whereas binomial distribution is applicable for discrete random variable, but the normal distribution is applicable for continuous random variable. So we will have to do continuity correction, because we are moving from the discrete random variable to continuous random variable. So if we do continuity correction, then it is going to be 28.5 less than x less than 34.5. So remember, don't forget to apply the continuity correction. Then we are going to find the z score. Z score is going to be, our z score is going to be, let me erase this. Well, it is going to be probability of 28.5 until 34.5. So if we standardize this score, it is going to be, 28 point z less than, sorry, 28.5 minus mean value we have already obtained, the mean value is 30 over standard deviation is the square root of the variance, which is square root over 18, less than z, less than 34.5 minus 34.5 minus our mean value is 30 and standard deviation is square root over 18. So if we do the calculation, we are going to get, let us do the calculation, 28.5, that means 1.5 minus um, 1.5 over square root over 18 is, definitely this is negative because 30 is greater than 28.5, so it is negative 0.354. Probability of negative point negative 0.354 less than z and less than, here if we divide 4.5 over square root over 18, 4.5 over square root over 18 is 0.1 1.061 1.061. Well, now if I draw a graph, look at this. Suppose this is our graph. Okay, let me draw the graph just beside this. This is our graph. So first z score is negative, which will lie on the left side, it is negative 0.3, and the positive z score is 1.6. Suppose here there is 1.6, and we are going to find the probability of this person. Okay, more than zero point 0.3 and less than 1.6 is the z score from the main line. So this probability, this red marked, red shaded zone is our probability. So for this, what we will do, we will find the probability when z score is 1.7. Well, probability of a z score when it is from the right side, sorry, we will find this portion when the probability, this probability should be found, then from that we will subtract this probability. Yes, we'll find this probability from which we'll subtract this portion, left portion. Okay, so let us find z less than 1.6, sorry, it should be 1.6, 1.6 minus probability of z less than negative 0.354, negative point negative 0.35 as well as 4. Okay, so these should be our scenario. Okay, now let me erase some of these parts. Well, so what we are going to do, we are going to subtract, look at this, when our z score is 1.0, then from which we will just subtract this portion, this black shaded part, this part should be subtracted. If we subtract this part, then we will find our desired probability, our required probability. Okay, well, so that's why what are we doing, we are just subtracting the left part when z score is negative 3. So one after the other, it is not 1.6, it is 1.06. I think we should write here not 6, it is 1.06. Z less than 1.06. 1.06, 1.06 minus, then we will have to draw one more curve. Probability of z less than 1.0606 minus. Now about this black shaded part, about this part we require only this portion. Okay, if I draw one more graph, look at this, with the same ink, we require to know, we require this part. Okay, this black shaded part, this part. So for this, how will we get this? From whole of this, look at this, the normal distribution graph is always symmetrical. Okay, so if here it is, here it is point 0.3, then here definitely it is 0, and on the right side of 0 it is point 0.3, positive point 0.3. That means we require the probability of this region. Okay, this region is our requirement. So how can we find the probability of this region? Very simple. If we subtract point 0.3, when probability is z score is point 0.3, if we subtract the left side, let us do the subtraction of the left side. Suppose, yes, we will subtract whole of this red shaded part from 1. If we subtract this red shaded part from 1, then we will find our tiny part when z score is point 0.3. I think you have understood. This is how we can find the probability of this region. This region can be obtained from whole of the probability. I mean, whole probability means 1. From 1, if we subtract this left side when z score is zero point 0.3, if we swipe the negative z score to the positive z score, then we will find our required probability of this tiny black part. So how to write this? We will write 1 minus 1, minus is going to be positive, when z score is z less than point 0.3, point 0.3. Now you may raise a question, not point 0.3, it was 0.354. You may ask a question that why should we required to swipe this to the right side? Because none of the probability given in the probability distribution table is applicable for any negative z score. All the z score given in the probability distribution table is positive. That's why we always convert the negative z score to the positive z score in the normal graph, because normal graph is always symmetrical. So let us find our z probability, corresponding probability when z score is 1.06, 1.061. Okay, 1.061, and the other one is the z score is 0.354. One after the other, 1.061. For this, let us have the image of normal distribution. Yes, normal distribution table. Okay, not this one. We will have to have this on a different page. Let us have on this page. Okay, it is normal distribution table, this. Okay, so for this, yes, this is our normal distribution table, and here our z score was what? 1.061. We should not forget this, 1.061. So 1.061, this is 1.0, 1.0, then 1.0 is over here, then 6 is over here. So row is this one, and column is over here. So this is our corresponding probability, and 1.06, the last digit is 1. So it is just going to be here, over here. So if we add up 0.8554 plus 2, it is going to be 0.8556. 0.8556, the first probability. So let us write, and the second probability, second z score was our 0.354. So for 0.354, point 3 is over here and 5 is over here, next digit 4 is over here. So let us find the row is this one and column is over here. So this is 63, 68, and for 4 it 14 should be added. So 68 plus 14, that is going to be 68 plus 14. Sorry, it should not be 14. We crossed the row. It should not be here. It is actually third row. So for third row, it is 15. Yes, this one. If we add up this 15, so it is going to be 6, 3, 15 plus 68, 83. So one is 6, 3, 83, and when our z score is 1.061, then our probability is 0.8556. So first one is 8556 and second one is 86383. So let us write there. So from when z score is 1.061, our probability was 0.8556 minus 1 plus probability on z score was 0.356, 0.356 our z score, and corresponding probability was 0.6383, 0.6383. Now let us do the calculation using our calculator. 0.8556, 0.8556 0 is our final probability. 0.490 is our probability. So I think you have got all the points I clarified. First of all, the question told to approximate, and for approximation, always we find we convert the binomial distribution into a normal distribution, because approximation indicate that it is given in binomial distribution which is to be converted to normal distribution. After that, here there is a twist in the question that they didn't tell directly to find the probability of a score. They have told to find the probability when there is a range of values given. Yes, more than 80 but less than 75. So in that case, first of all, we did the continuity correction, because we are converting a binomial distribution into a normal distribution. After that, we found the corresponding z score. After finding z score, one of them was negative. So negative z score can be obtained always. It is swiped to the right side. After that, from 1 we just do the subtraction of that tiny part, because none of the probability given for any corresponding negative z score in the probability distribution table. All that's why always we find the probability of positive, corresponding probability of positive z score, then we subtract that from 1, and that is how we solve this. So that's all about the solution to the last question of this paper. I mean question number 7. This is the first part, a b c, and the final part is this. So thank you all for being with me. May Allah bless us all with beneficial knowledge. Fi amanillah.